Hello, welcome to PhyzQuest. So this is the solution video for CSIR NET December 2019 Part C, question number 24. A circuit diagram of bandpass filter is given here, where resistance R is 10 kilo ohm. Now in order to get a lower cutoff frequency of 150 Hz and an upper cutoff frequency of 10 kHz, the appropriate value of capacitance respectively we need to find out. So 4 options are given and we need to choose the correct option. So let's get started. So this question comes from the section electronics and the concept involved here is op-amp. Now we know that operational amplifier has many applications. Filter circuit is one of them. In the given question, we are given the circuit diagram of a band pass filter. Now, what is a band pass filter? A band pass filter is a filter circuit that allows signals of certain frequency range and rejects signals of outside their frequency range. So the frequency range which is allowed is called pass band. Now the lower and higher cutoff frequency in this range can be controlled when the filter circuit, the band pass filter circuit is formed by connecting a single low pass filter with a high pass filter circuit. So this is formed by cascading the connection of high pass filter circuit with a low pass filter circuit. Now as I said, band pass filter has two cutoff frequency, lower cutoff frequency and higher cutoff frequency. Now this lower cutoff frequency is decided by the high pass filter circuit. Why? Because high pass filter is the filter circuit which allows only signals with frequencies higher than the cutoff frequency. So frequency lower than the cutoff frequency will be blocked. Now the high pass filter circuit can be formed by using operational amplifier with resistor and capacitor connection, where the input signal is applied to the capacitor and output is taken across the resistor, which is the highlighted part in the circuit. Now the lower cutoff frequency from a high pass filter is 1 by 2 pi R C1. Similarly, the higher cutoff frequency is decided by a low pass filter. So because low pass filter is the filter circuit that allows only signal with frequencies lower than the cutoff frequency. So frequencies higher than the cutoff frequency will be blocked. Again, this low pass filter circuit can be formed by using operational amplifier with resistor and capacitor, where the input signal is again here applied to the resistor. Earlier it was applied to the capacitor. Now an output is taken across the capacitor, which was earlier the output is taken in the resistor in case of a high pass filter, where in case of low pass filter the output is taken across a resistor, across the capacitor. So this is this part of the circuit. Now here again, as per the formula, if you want to calculate the higher cutoff frequency of the low pass filter will be 1 by 2 pi R C2. So these are the two formula which we need to solve this problem. The question here is, we are given a band pass filter circuit where the one part is high pass filter and another part is low pass filter, and we are given the respective cutoff frequencies. And here we need to calculate the capacitance value C1 and C2 respectively. So we need to use these two given formula to do that. So here the lower cutoff frequency is given as 10 kilohertz. So by using this the formula, first formula, that is 1 by 2 pi RC1 will be equal to it is equal to, sorry, not 10 hertz, it is equal to 150 hertz. Okay, so this is your lower cutoff frequency. So if we do put the values here, your resistance is 10 kilo ohm. So now let's put the value. So this will be, C1 will be equal to 1 divided by 2 pi into 150 into 10 into 10 to the power 3, because it was 10 kilo ohm the resistance. So now when we solve that, this will be equal to 0.1 into 10 to the power minus 6 farad. So therefore C1 will be equal to 0.1 microfarad. Similarly, to To calculate the higher cutoff frequency is given as 10 kilohertz. Therefore, if you use the second formula, that is 1 by 2 pi RC2, this will be equal to 10 kilohertz. So here C2 will be equal to 1 divided by 2 pi into 10 into 10 to the power 3 into 10 into 10 to the power 3. So here this one is for one is for the frequency 10 kilohertz, so 10 into 10 to the power 3, and another one is for resistance, that is 10 kilo ohm. So again this term 10 into 10 to the power 3 is given. So ultimately when we calculate that, final answer will be 1.5 into 10 to the power minus 9 farad. So that means C2 will be equal to 1.5 nanofarad. So we have got the value. C1 is 0.1 microfarad and C2 is 1.5 nanofarad. So let's check the option now. So when you check the option, you can see that option A is matching with our result. So correct answer for this question is option A.